One of our goals is to be the coldest lab in Canada, to have the coldest experiment in Canada. Roughly 300 microkelvins. That's right, minus 273.1517 Celsius. We think of particles in classical mechanics as being rigid objects, but in quantum mechanics we think about waves. Quantum mechanics just tells us that everything that's a particle is also a wave. There's this duality. We go to extremely low temperatures to explore this crossover, whether or not we can actually make classical objects behave quantum mechanically. What we have is essentially two refrigerators. So what we'll be doing is putting nanofabricated objects and the measurement apparatus inside this fridge. We're really just exploring these fundamental questions to a large part, but practical applications always fall out. You don't go after that. You train people in science, you explore the world, and you figure out what the world has to tell you. I went to graduate school at Northwestern University, and that's in Chicago. There was a local coffee shop in Evanston. I walked past this gal one time, and she was reading a chemistry textbook, and I said, hey, what's that?
Well, actually, I think he said, is that an undergraduate textbook? It's kind of a weird way to strike up a conversation.
She'll tell a different story, that we met some other way.
I saw him at some graduate student gathering, although he doesn't remember me from that, but I remember him because he's kind of noticeable.
And so that's how we met. She's kind of a superstar, and she had 14 job interviews that year and 9 job offers, or 8 or 9 job offers. It was really ridiculous, like unheard of. Because she had so many opportunities, basically I got to sort of help choose.
Very happy to be here. It's been really good for both of us. In terms of our lab and our infrastructure, I don't think it could be better anywhere, really. I have what's called a materials chemistry background. One place where that's really useful is making materials that can be used to detect whether or not someone has a specific disease. Because in order to do that, you have to recognize something associated with that disease. In this case, it's a little piece of DNA, and then cause a chain of reactions. So you have to make molecules that can somehow change themselves when they see this DNA. So we've developed systems that will amplify a particular sequence associated with tuberculosis, but we're still in the early stages. But places where we think this is really important is in developing countries where they have huge problems with disease, particularly drug-resistant strains, and they need new techniques. We are definitely each other's cheerleaders, but we're also competitive, and so we're usually aware if we're applying for the same thing, see who gets it.
I basically just got an email from the president of the Sloan Foundation that said, congratulations. And you're like, wow. I mean, first off, this is amazing, right? And so obviously the first thing I do is I pick up the phone and I call Julie.
And so my first instinct was total excitement, oh my God, you got it. And then I thought, oh my God, I didn't get it.
She was genuinely happy for me. And then she said, wow, I didn't get it. And I said, how do you know you didn't get it? And she said, well, they didn't contact me.
And so I checked my email thinking,
Boom, there it was. She had got it in it as well.
Show how strong your neck is already?
Yeah. How is his head going to get strong if he doesn't?
No, that's not how it works, actually.
Of course it's how it works. You don't know what you're doing. We're just trying to figure it out day by day. Luckily, they don't know any better, so he's just happy, so that's all that matters.